Protecting the Earth from asteroids. NASA is about to undertake a test. Welcome back to Techstination. I'm Fred Fishkin. On Monday at 7:14 p.m. Eastern, NASA's Double Asteroid Redirection Test, or DART, will intentionally crash into a small asteroid named Dimorphos. Joining us is Lisa Wu, mechanical engineer at Johns Hopkins Applied Physics Laboratory, which built the DART spacecraft and is managing the mission for NASA's Planetary Defense Coordination Office. Hi, Lisa.
Hello. Thank you for having me.
Terrific to see you. And first off, this is a test coming up. So describe what is being attempted here with DART.
Sure. So as you mentioned, DART is impacting an asteroid. This is NASA's first planetary defense test mission. So I do really want to emphasize that it is a test. We are impacting this asteroid, but this asteroid system has no route towards Earth. We are fine before and after impact. So definitely want to underline that. This is a really cool mission because we are testing one of the viable techniques for redirecting an asteroid. So this is what we call a kinetic impact. And through this kinetic impact, we want to transfer our momentum to this asteroid and change its orbit around its larger asteroid, which is called Didymos.
And the goal is to see how much you can throw this off. Is that the idea?
The goal is to impact it and prove that we have the technology right now to do a mission like this. So something that's really cool about DART is about 4 hours out before impact. That is when the whole system is autonomous. So it is guiding itself to the asteroid. We are not joysticking it on the ground. It is going and it is doing its thing. So this is a really interesting technology that APL is really well centered to accomplish with our various departments at the lab.
How important is this to be able to accomplish something like this?
You know, we have the technology right now, and asteroids are a natural hazard. They happen all the time. In the last 40 years, there's a lot of asteroids that have hit Earth, but many of them are so small they burn up in the atmosphere. We are covered by a lot of water on the planet. A lot of them fall into the ocean. It's the larger ones that we are concerned about. There has been one that flew over Russia in 2013, and it impacted a city and it blew out windows, and it was a really bad natural disaster that had we had DART, this type of technology, we could have seen it and then impacted it. Just give it a little nudge just to throw off its trajectory so it would not impact Earth. So things like this is a natural disaster, and these are things that we have the technology to prevent. So let's prove that we can do it, and in the future, do it.
Will you know if this is successful right away? There's an accompanying little thing called cubesat traveling with DART. Tell us how that's going to work.
Yes. So the CubeSat is called LiCaCube. So it is the light Italian CubeSat. It was provided to us by our friends over in Italy. DART is an international collaboration. I do want to point that out. So it was really fun having to working with them. They're fantastic. So this CubeSat actually deployed about 10 days ago. It was 10 days ago. And this CubeSat will be taking pictures of the impact. So the downlink rate for the CubeSat is actually gonna be a while. So it's gonna be a while before we actually get the pictures down, but we will know immediately if the mission is successful because we will lose communications. So our mission operations folks, they will be intensely staring at that computer Monday night, waiting for that signal to just deadline.
And is it packed with explosives or something? What's it going to do?
I get that question a lot, and that's not unreasonable, but we do not have any explosives on the spacecraft. This is purely momentum transfer. So DART is roughly the size of a smart car. It weighs like 1,200 pounds. So it's relatively a small spacecraft compared to things that we have launched before. And this bigger, the asteroid, we're hitting the smaller one, but this asteroid is larger than DART. It is roughly the size of one of the Great Pyramids. So you can just imagine we're throwing a smart car at a pyramid. Yeah, that's a very interesting concept to think, but we are sending the spacecraft real fast. It is going 14,000 miles per hour, which is roughly 4 miles a second. So you can imagine that's going really, really fast. And momentum transfer is mass times velocity equals mass times velocity. We are conserving all of this momentum. So by us hitting the asteroid, we are imparting our momentum to this asteroid. And that is what we are testing with this kinetic impact. By giving it that little bump, we are predicting that we will be changing its period around the larger asteroid. So I should back up a bit and explain that this asteroid system is a binary system. So what that means is we have the larger asteroid, which is called Didymos, and a smaller asteroid, which is called Dimorphos. Dimorphos is orbiting around the larger asteroid, kind of like how we have a moon that goes around us. So we are hitting the smaller asteroid. The smaller asteroid right now has a period, which period means how long it takes to go around the bigger asteroid. It takes roughly like 12 hours to go around. Even though we are going super, super fast, we only want to give it a little nudge. So we predict that that's going to change the period by roughly 10 minutes. So at the end of the day, we predict that the new period, the orbit around the asteroid, will be roughly, instead of 12 hours, it'll be 11 hours and 50 minutes. So it is a small nudge, but this nudge is enough to prove that, yes, we have the capabilities to target a small asteroid that is 6.7 million miles away. And it does indeed work.
Would the technique be different for larger asteroids?
There are several techniques out there. I am not particularly an expert on those, but this could be a method. We only need a little nudge. If we know far in advance, if you little push very, very far out, that can completely change the orbit when you think on the grand scale of millions and millions of miles. You just need a little nudge. So yes.
How long has the planning been going on for this, Lisa?
Oh man, DART has started out. It's been a while. I came onto this halfway through the program in roughly 2018, 2019, but I know that this was a concept study at the Johns Hopkins Applied Physics Lab in the early 2010s. They were thinking about this. They were planning the mission. They're like, how are we going to execute this? And then through the years, it got funding. People were really interested. The Planetary Defense Office at NASA was established in 2016. So you can imagine like everything is gearing up to do something like this, to do this test.
You know, everybody wonders, and you've given us some thoughts on this. How likely is it that we're going to be faced with the real thing here, an asteroid, a significant one, I suppose we could say, threatening the Earth?
Yes. Okay. So I guess I'll start on the grand scale of things. On the grand scale, we have the asteroids that are, say, like 10,000 meters in diameter. Those asteroids are what we consider the dinosaur killers. Very scary. But, you know, they're so large that we can track them. And part of planetary defense is tracking, characterizing these threats. Are they a threat to us? Now, these, what we consider dinosaur killer asteroids, we have tracked all of them, and we are safe for the next at least 100 years. They are not on course to hit Earth. So that is great news for us. A step down, you have the asteroids that are roughly 1,000 meters, and those are pretty devastating. They would maybe wipe out a state. Not great. But those we are also tracking, and since those are larger, we can track all of them, and we have 95% minimum tracked, and we are actively tracking and characterizing, are they on a collision course to Earth? And no, they are not. So you know what? That's great. We have those really big threats. We are actively monitoring them, and we are safe. Now it's the other ones, the ones when you step down to like the 100-meter, those are the ones that would create large craters. Those are the ones that in 2013, they hit a town in Russia. Those are pretty devastating. They are a natural disaster similar to hurricanes and tsunamis, right? But this is something that we can prevent. So these we are actively tracking, but we need more knowledge in order to track all of them. So at the end of the day, we want this is what we're trying to, DART is one of the techniques that we are proving that we can do. So then we can address those smaller asteroids that could cause devastation to towns and cities. So
are there many of those? And do we know that I guess we can't really know, but do we think we've located most or all?
We are actively working. I believe we have tracked over 50% of them. So the Planetary Defense Office is actively working towards tracking all of them. So then we'll have it in our database and we'll be monitoring it.
Well, terrific. And we wish you lots of success there, you and the whole team. Lisa Wu, thank you so much for spending time with us.
Of course. Thank you. Thank you.